Well, hello, everybody, and welcome to Monday. I hope you all had a wonderful Thanksgiving break and that it was restful and that you're ready to get back into the swing of things with school for the next couple of weeks until we hit the Christmas break. So, today we're going to begin starting a new concept called scatterplots, which is all about gathering and analyzing data. So, go ahead and pop this open, and we'll get started with our guided notes today, followed by the assignment. So let's begin with what are scatterplots? Well, the points of real life data don't always lie on a straight line. So we have in a scatter plot a coordinate plane display, and it's displaying two sets of data, and it's a graph that relates two sets of data. And the data is plotted as ordered pairs on the coordinate plane. So as you look at the four diagrams below, you can see that all of them are points plotted or ordered pairs plotted on the coordinate plane. Okay? And these scatter plots are used for comparison. So we can see if there's a correlation between the variables. We'll also use the words relationship and association when we're talking about what we see with these two between the two variables that make up our sets of data. So if we start here with our first example, and if you look at your points on this particular coordinate plane, they are increasing from left to right. So if we simply apply what we already know about a line, when a line is increasing from left to right, we know that it is positive. So these points are increasing from left to right, and they have a positive correlation. And what that means, as you see below that, is as one set of data increases, the other set increases as well. So if you look at this, as your y values are increasing with each of these ordered pairs, your x values are also increasing as well. Now, each of these sets of data, with the exception of the no correlation, have a line drawn through them. And we're going to learn about this line tomorrow, but this is called the line of best fit, and it helps us to analyze the data. So if you look at this first graph, you'll see that the points are all very close together, and they're very close to the line. So that's what we call a strong correlation. If you look at the next graph, these points are increasing from left to right, but they are not close together, nor are they close to the line. So this is what we would call a weak correlation. Okay? So if you look at the third graph here, this one is called no correlation because there is no visible relationship between the variables. So this one here, they're just sort of scattered everywhere with no particular pattern that's increasing or decreasing. I like to think of this one as the shotgun blast. It's just everywhere. So when you see a graph like this where your points are just everywhere, that they're neither increasing nor decreasing, this is what we call a no correlation relationship. Now, if we come over here to the next two examples, and again, using what we know in our definitions of line, our points or ordered pairs on this example are decreasing from left to right. So since they are decreasing from left to right, that's going to be a negative correlation, okay? And our other one here as well, the points are decreasing from left to right, so that's going to be a negative correlation. And again, notice how the points over here are neither close together nor are they close to the line of best fit. So we call that a weak correlation. Whereas here, our points are close together and close to the line of best fit. So we call that a strong correlation. Now, when you're looking at your negative correlation, you need to keep in mind that as one set of data decreases, the other set of data increases. Okay? So if you look over here, here's my y-axis. My y values are decreasing, but my x values are increasing or getting higher. Okay? So you need to keep that in mind because when we look at the statements below and talk about the different types of correlations we see, we need to bear in mind, are both sets of data increasing together or is one decreasing as the other increases? All right, so I'm going to go ahead and open this in Kami, and we'll go through the ones below and then we'll get started on your assignment. All right then, so the question is, do the following sets of data have positive, negative, or no correlation? So number one says the age and weight of a baby. Now, generally speaking, as a baby gets older, the weight increases. Okay? So both of these are increasing. As the age is increasing, the weight is increasing. So both sets of data, we're going to put here increase. So the data has a positive correlation. All right, and there again, you could use the term correlation, relationship, or association. So they have a positive correlation. So number two says, the amount of free time you have and the number of sports that you play. So if you think about this, think about your free time, which would be the time you have outside of school. Is your free time going to increase or decrease if you play more than one sport after school? Well, your free time is going to decrease because you need to give more time to each of those sports that you're committed to. So the free time decreases as the number of sports you play increases. So because one is decreasing as the other set increases, the data has a negative correlation. Okay? So let's look at number three. It says the price of a shirt and the color of its buttons. The price is not affected by the color of its buttons. So the data has, and this is going to be no correlation. All right, so if I have a blue shirt with white buttons, that generally does not make any difference in the price of the shirt. And if I had a yellow shirt with white buttons, the color of those buttons, again, wouldn't make any difference in the price of the shirt. Okay? So let's read statement number 4. It says the number of hours a plane is in flight and the number of miles flown. So the amount of time you're in flight is increasing and the number of miles flown is increasing at the same time. So because both of them increase, this is going to be a positive correlation. All right, the next one says the number of hours flown, or the number of hours in flight, and the number of passengers. So, does the amount of time in flight, is that really affected by the number of passengers? No, it is not. You can have 10 on board or you can have 50 on board. The number of hours in flight would still be the same. So this is going to be no correlation because one is not really affected by the other. And then our last one says the number of hours in flight and the gallons of fuel remaining. So the longer I'm in flight, that is a set of data that is increasing. But as I fly longer, my fuel decreases. So this is going to also be a negative correlation. All right, so that is our notes for today. So if we look down then, we have 6 different scenarios that you're going to look at, and you're going to analyze and interpret the data on each of these. Okay, so where you're going to do this is if you notice on your assignment that right below your notes, here is the embed for you to use, and you're just going to submit it once you're done. There's no need to make a copy and share it with me. Just submit and everything will be okay. So here's what you're going to do is you're going to look at the scatter plot. And then when you go to the PowerPoint or the Google Slides, there's 1, 2, and 3, and then the next slide's going to have 4, 5, and 6. And there's 4 questions to answer on each of them, and it's the same 4 questions. So for number 1, it says here, what is the x variable and what is the y variable? So when you go back to this particular scatter plot, of your x variable is going to be the horizontal x-axis, and your y variable is always going to be the y in the vertical axis. So your x is the price of car in thousands, and your y is the miles per gallon. All right, so here you would just come underneath, and you would type x, and that's going to be the price of the car in thousands. And then y is going to be the miles per gallon. All right. So then the next question is, what question is someone trying to answer with the data? So you're going to look at both of your variables, which is the price of the car in thousands and the gas mileage, or the miles per gallon, and you're going to ask yourself, what are they looking at? And what they're trying to answer is there a correlation between the price of a car and its gas mileage? Okay, that's the question that we're trying to answer there. All right, then for number 3, it says, what type of correlation is there in the data? So again, if you look at it, since it is decreasing from left to right, and as your price increases, your miles per gallon are decreasing, this is going to be a negative correlation. Okay, and then what conclusion can you draw from this data? The conclusion that we can draw is, as the price of a car increases, the gas mileage decreases. All right, and that's all you're going to do for each of them. Okay, that is all you're going to do for each of these. So if you have any questions, I will be up on Google Meet, or you can send me an email and I will get back to you as soon as I can. But once you're done with this, just simply click the submit button on Canvas and it will submit it to me, and I will be able to see it. And then tomorrow we'll start learning about the line of best fit. All right, everybody. So have a great day. Thank you for your attentiveness. And again, let me know if you have any questions through Google Meet or through an email. All right, have a great day.